Alright, so this is a Pythagorean Theorem word problems. It's a practice sheet. This is like that last real thing we doing before we do study guide, and then we're gonna take the test. The problems on this sheet you need to focus in on. These are the type of problems we like to ask y'all on the test, because it's a culmination of everything you learn in this unit, pretty much. Number one is a good example too. I want you to actually start number one and number 4 on the back. These problems are very similar. The only difference between the two is kind of the shape, and then number 4 on the back doesn't have a graph to go with it. So when you get ready to do number 4 later, you might want to choose to use some graph paper and redraw that on graph paper and then solve that problem. It may become easier to you, especially after you see me do number 1. We didn't put a graph on here for a purpose to make you make a decision. You don't have to use a graph, but you can use a graph if you're gonna do it kind of like my way with Pythagorean. Alright, so number 1, it says in the diagram below, a bike ramp built on a hill has vertices. They give you those vertices out here, A, B, C, and D, and then they even label them on the graph. It says to make sure that the ramp is sturdy enough, Raphael wants to add a straight piece of steel tubing that connects the midpoints of AD and CB. What would the length of the steel tubing in simplified radical form be? So, like I say, this is a setup for his bike ramp or whatever that he's building. He wants to add a piece of steel tubing to reinforce it. He said the piece of steel tubing is going to be connected at the midpoints of AD and CB on both sides of the ramp. So they're telling you all that so you can figure it out, and then they want to know how long the piece of steel tubing is. You first need to find the midpoint of AD and CB. Once you find those midpoints, you'll know where the piece of steel tubing will be connected at. You'll know the exact points. Then from there, flip your mind. Then after that, you want to know the length of that actual piece of steel tubing once you put it in, and then that'll be distance. So on this problem, we're doing 2 different skills that we learned. We're doing midpoint first to find the midpoint on each side, figure out where the tubing will be connected at. Then after that, we need to do distance, or Pythagorean theorem, to find the length of the steel tubing. So starting out, we're going to do a midpoint of side AD and CB. This will tell us where the steel tubing will be connected at on both of those sides. So AD first, and like I said, I label stuff so I know what's going on with what. So I'm doing midpoint of AD. So AD, those 2 points are up here already, so we can really just label them. A, I could call it X1, Y1, D, X2, Y2. Label those points up there for yourself, and then you should use the midpoint formula on this one. Y'all should all know it by now. Add the x's divided by 2, add the y's divided by 2. X1 is -5 plus X2, which is -2, divided by 2, comma, and then you have 1 plus 7 divided by 2 for your y's. And the midpoint equals, down here I'll do it line by line with y'all. You're going to get -7 divided by 2, then you're going to get 8 divided by 2. Simplifying that out, m equals, now on this one, they asked for our answer for the length of the steel tubing as a simplified radical, but they didn't say anything about our midpoints. I'm going to go ahead and get decimals for my midpoints so I can actually put them on the graph. So I can see them on the graph, and I can figure out my length of my steel tubing. So -7 divided by 2. Anybody with a calculator, what decimal you get? -3.5. And then 8 divided by 2, you should all know that's 4. So my midpoint for AD is -3.54. So zooming in on my graph so you can see me graph this. On the graph, I'm going to actually put this point on there. I'm going over -3.5. So -1, 2, 3. 0.5 will be in the middle of this next line. And then I'm going up 4. 1, 2, 3, 4. I land right here. This will be my midpoint for AD at negative 3.5, comma 4. I should be okay with this so far. I ain't did nothing crazy yet. Zooming back out. Now we need to do CB. So I need to do midpoint for CB, my other point. I'll change colors. CB I'm doing green. I'm doing midpoint again. You can label. So let's say CB, I'll do C first. X1, Y1, X2, Y2. Then after that, put it in the midpoint formula. M equals, my X is 3 plus 6 divided by 2. And then my Y's, which is 5 plus negative 1 divided by 2. So I'm going to get 9 divided by 2, comma, 5 minus 1, plus 1, or plus negative 1 is 4. So 4 divided by 2. And then midpoint equals, get the decimal, 4.5. I don't know why I'm putting a plus sign right there. Should be a comma. Make that a big comma. Comma 2. Alright, so my other point for my other midpoint on CB is at 4.5, comma 2. So going back to my graph, I'm going to put that point on as well. Over 1, 2, 3, 4.5. And then up 1, 2. My midpoint right there would be at 4.5, comma 2. So these two midpoints create the points at which we're going to connect that steel tubing. So that steel tube, I'm a little index card I have. It's going to go from one midpoint to the other. I'm going to just draw a line. You can use ID or whatever you have as a straight edge, or you can just try to wing it. You don't got to be straight. So that's going to represent my steel tubing right there. That piece. They want to know the length of that. Now to know the length of that, that's when you need to do distance. You can either use the distance formula, because you do have the set of points, so you can label these and do distance formula on them if you want. But y'all know from experience with me so far, I do Pythagorean anytime I can. I don't like using distance formula, but it's up to you. So I'm going to draw my triangle like I always do. And I'm going to do Pythagorean. Triangle here. It's a right triangle. This side right here is going to be my C. And then from there, I just need to get my other two sides so I can do Pythagorean Theorem. Going down is easy to count because it's right on directly on lines. It's just two spaces, 1, 2. So my vertical change will be 2. Going over a bit, the harder count, because you're in the middle. You're in a half spot on both sides. But since you're in a half spot on both sides, it's going to come out to be a whole number. You just got to count right. I counted wrong last period, and we had to correct me. Alright. So starting here, counting my horizontal, I'm at a half spot, so I'm going to just keep counting the halves and call that a whole. So going over, in the middle will be 1, in the middle will be 2, middle will be 3, the middle will be 4, middle will be 5, middle will be 6, middle will be 7, then I land on 8. Going over is 8 spaces. Now follow what I just did. Alright. So my two numbers are 2 and 8 that I'm going to use for Pythagorean. Alright, so from there, 2 squared plus 8 squared equals C squared. And then you got 4 plus 8 squared, which is 64. C squared. Add those together. You're going to get 68. C squared equals 68. Square root. Cancels here. You're going to be left with square root of 68 equals C. But your answer has to be in simplest radical form. This radical is not simplified. That's why we did what we did before we started anyway. So we know how to do this now. 68 is one of the not harder ones. It's just not as easy to do. But you know, any even number can be multiplied with what? Like 2 and another number, right? So 2 and what will give you 68? So 34 times 2 here. Then after that, 34 can be broken down as well. What's half of 34? So 17 times 2. You follow me? Then from there, what double numbers do we have? I'm asking what double numbers? The 2's, right? So when I rewrite the simplified radical, how am I rewriting it? 2 square root 17, yeah? Equals C. So that's going to be my answer. That's my simplified radical right there. And then that's what you're going to put in that box down there. That will be the length of the steel tubing in simplified radical form. 2 square root 17. Let me zoom out some. So there was a lot going on with that one. Guaranteed. But this is all stuff y'all are capable of doing. All this has been taught to you already. You just got to put it all together and solve that kind of problem. This kind of problem will be on your test. I'm not going to lie. This type of problem will be on your test. Alright? You just need to understand you need to do midpoint on both sides real quick. Then do Pythagorean. Solve for the distance of the piece of tubing or whatever we ask you about. Any questions on that one before I slide on number 2? So once again, number 1 and number 4 pretty much identical. If you look at number 4 on the back, it's talking about the midpoints of A, B, and C, D, and then after that it says find the length of the segment formed by joining those midpoints. So you're going to find the midpoints, make a segment across there, and find the length of that. Same thing as we did on number 1. Only thing is it's not on the graph for you. You're going to need to put that on the graph for yourself and do it. Alright, and look at your answer choices. Your answer choices are all simplified radicals. They didn't tell you to simplify the radical, but down here, obviously, since all your answer choices are simplified radicals, you know that's how you got to give your answer. Alright, number 2 on the front. Let's look at this one. This is the last one, like I said, I'll do with you. I'll probably help you with setup on number 3, but that's it. Number 2 says the city of Jacksonville wishes to build a sidewalk across a rectangular shaped park. The park has measures of 135 feet by 180. How much will the city spend if it costs $24 per foot to have a sidewalk built? So on this one, reading the problem, what shape is the park? Rectangle. So obviously you should know what shape you should be drawing on your paper first. It's always best to draw these situations out if they're not drawn out for you. Draw a rectangular park for myself. Then after that, I'm putting my measures of my park in. Say my park measures 135 feet. So my shorter side will be 135. My longer side will be 180. And then they said they wish to build a sidewalk diagonally across the park. So diagonally in this park, I'm going to have a sidewalk coming through. And they want to know how much it's going to, cost to build the sidewalk. But before you can figure that out, you need to know the length of the sidewalk. So based on what we drew and set up, you should be seeing that we created on this side down here a right triangle, yes? Of that right triangle, when we label, which side will the sidewalk represent? If we were to label with letters, that would be my C, right? Yes. And then the other two would be A and B. Like I said, I always do my shorter leg as A, my longer leg is B, but it don't matter. You just need to make sure you identify stuff correctly. That's going to be my C. So now you're ready to do Pythagorean. Pythagorean out here, 135 squared plus 180 squared equals C squared. Then from there do the math. These numbers will be big, but you'll be alright. 135 squared. You get 18225. And then 180 squared. 32,400 equals C squared. Add them together. You're going to get 50,625 equals C squared. And then last thing y'all need to do, square root. Square root cancels. What you get? Heard somebody say it. 225, this is feet, equals C. So the length of our diagonal is 225. Now this is the thing though, you don't read this question, you're going to get excited and you're going to look over here to your left and you're going to see 225 as the answer choice and you're going to circle that, but you would be wrong, wouldn't you? Alright. And I was telling the kids in the other class, we do this for a reason. Anytime you see us do multiple choice, more than anything, we just trying to fool you. We're going to have the wrong answer on that you might see, but it might not be the right answer. You make sure you read the question right and do like, anytime we do multiple choice, you should be suspect of us. Because we don't do a lot of multiple choice questions on our tests. Mainly our tests look like this kind of. It's mostly write out. Like 4 out of the 6 problems on this sheet of paper are write out problems. That's how our tests look too. Anytime we do multiple choice, more than likely we're trying to make sure you on point and you reading questions correctly and answering the question correctly. So 225, that is not my answer. That's just the length of the park. After that, to figure out how much they're going to spend, you need to take that 225 feet and do what? Multiply it by $24. So 225 feet, you're going to times that by $24. And then the amount of money they'll spend is what? $5,400. And that'll be B for y'all. I mean, if you needed me to circle it, obviously. Marius, we almost done. Alright. I left them alone after this, but I kind of want to set this one up for you, just so you can see you're not doing a whole bunch of work. So in this one, it says the vertices of a horse fence have coordinates of J, K, L, and M. I don't feel like reading the numbers. Determine the perimeter of the fence. If each unit of the coordinate plane represents 10 feet, round to the nearest foot. So first you got to find the perimeter of the fence. Y'all know how to find perimeter now. But then after that, they say each unit represents 10 feet. So once you find the perimeter, what are you going to do before you give me the final answer? I'm asking. Huh? Yeah, no, I'm saying once you find the perimeter, since each unit represents 10 feet, what are you going to do? Huh? Yeah, you're going to multiply that number by 10 to get the feet. But yeah, the first thing you have to do, you need to plot these points and see the shape. So all y'all should be graphing. Don't wait on me to graph. I wasn't even supposed to be doing this one with you. So -3, 1. -3, 1 is here. It's my J. K is at 1, -5. 1, 2, 3, 4, 5. L is at 7. 1, 2, 3, 4, 5, 6, 7. Up 2. No, down 2. 1, 2. And then M is at 3, 4. 1, 2, 3. Up 1, 2, 3, 4. So when you're looking at this and you're like, well, I got to find perimeter. That means I got to do Pythagorean 4 times. What I want you to do in problems like this, because a lot of times this happens, draw all your triangles and stuff and label first, just so you can compare them. So what I'm saying is, I'm going to draw my triangle for JK so I can do Pythagorean. Drop here, come over here, right angle. So my count on JK would be 6 and then 4, and then I'm going to do KL. My count on this one horizontally would be 1, 2, 3, 4, 5, 6, and then going up would be 1, 2, 3, and then if I do LM, my count on this one is going to be up 6 and then over 4, and then my last one, this one here, JM, and get 6 on top and 3 down the side. The reason I make you draw your triangles first is so you can kind of slow down the amount of work you're doing. So looking at this, I got sides that are the same, yeah? If my sides are going to be the same, then the length of those segments that I'm looking for are going to be the same, yeah? So I only have to how many times do I really have to do Pythagorean on this problem? Twice. But once you get that number, you need to make sure you double it to represent both of those sides. You follow me? And then after that, add them all together, and then times by 10 and round to the nearest foot. You should give me my answer. So like I said, sides that are the same, like JK and LM are the same. So my Pythagorean for that is going to be 4 squared plus 6 squared. Once I get that answer, I just need to understand that I need to double that, because it's 2 of the sides that share the same lengths. And so after that, just double your answer once you get to the end, and then do the other 2 sides, double your answer, and then add them together. Y'all follow me on that? I'm just trying to save you work. I don't want to see you do it 4 times if you don't have to. It's unnecessary. Some of the stuff is the same. Alright, so that's how you handle that type of problem. So we should be good. Everything else should be straightforward from there. Y'all should be able to handle it.